I'm Willem Ouwehand, Professor of Experimental Hematology at the University of Cambridge, with very important affiliations with University College London Hospitals and the hospital here in Cambridge. And I've been supported during my scientific career by NHS Blood and Transplant. I think maybe we should focus on the DNA technology and how you can type blood groups on red cells and platelet groups, or human platelet antigens on platelets, and the tissue types on white cells. They can all be typed by investigating the DNA. When I arrived here, we did one DNA test for one DNA variant, and we were very proud that we did 96 individuals. We then moved to a so-called technology called TaqMan technology, which is a technology by Thermo Fisher Scientific, where we could go from 96 to 9,000, but still for one DNA variant. And in the journey where we went to look at the whole genome, technologies emerged in which Thermo Fisher made an essential contribution to test up to 1 million DNA variants in a single test. Not for one person, but for tens of thousands of people. And I think it is that transition where we went from technologies that allowed you to do one variant in many people to a technology called array technology, where we can do 20,000 variants in 100,000 people. And that made me realize that that technology is so powerful that we could take that to the front line of transfusion and apply that. The Blood Transfusion Genomics Consortium is unique because of the people who are at the core of this consortium. With global leaders in blood group genetics like Connie Westhoff in New York, Alan van der Schoot and Barbara Veldhuizen at Sanguine in Amsterdam. Supported by first-class computer scientists like Dr. Bill Lane, here in Cambridge, Dr. Nicholas Weddell. It's this group of people, together with Thermo Fisher, that has developed an array and the software that's absolutely first in class in the world, and now has become available through Thermo Fisher to the global research community in transfusion medicine. We had a workshop in which we set out a proof of concept study and asked the question whether the array technology actually could work for blood group typing. We reported on that in 2020, and at that time we showed that we could type around 20 blood groups. So we then became for step 2 more ambitious. Say, let's take these 20 blood groups to more than 50 blood groups, and let's do the tissue types and the platelet types and markers for donor health and patient health. And the consortium in that sense has been unique by its global reach, and by the global reach of Thermo Fisher Scientific also, that we truly could bring DNA samples not only from people of European ancestry, but included a large number of people of African ancestry, Caribbean ancestry, and from India and Pakistan, and from China and Japan. There is a real need to reduce the side effects patients experience, particularly patients who need frequent transfusion of blood. We also need to improve the outcome of kidney transplantation. And we can do that by giving better matched blood to patients who need a kidney transplant. So there's a real urgent need to drive that research forward to show that we can make the transfusion of blood more effective and safer. The array technology from Thermo Fisher Scientific, also called the Axiom array, is an array that has been developed in partnership with Thermo Fisher since 2006. And we know that this array technology, if we take a set of DNA samples, apply it once, and we apply it in another laboratory somewhere else in the world the second time, that we get the same results. So it's a very robust technology. Secondly, there's a whole series of applications have been developed over the last 15 years that allows the quality control of these array data to be fully automated. And this includes important quality control measures like whether the DNA sample is contaminated or not. So there's a lot of power and proven performance of this array technology, and that's the reason why we as a consortium selected it to make the next development step for the blood service. My hope for the blood services is that there will be a transformation the way we type donors and the patients. And to type them by array technology, we can match the blood we give from the donor to the patient better, and thereby reducing the side effects. But there are more exciting developments coming. Software application that can help scientists make an informed choice about the best matched blood, if your donors are well typed and if the patients are well typed. Wouldn't it be immensely exciting if we could find the genetic markers that identifies the patients that are most at risk of reacting on donor blood? Because then we can select the matched blood for them most at need. The most important one is that around 5% of patients have reactions against donor blood. And we have no idea why that is the case. And I would suggest that it is very likely that this is to a large extent genetically determined. And with the array technology, we can find the genetic markers that determine whether someone is at risk of reacting or not.